Welcome to the final chapter in the course on analysis of beams, namely slope and deflection in beams. Let us first understand why the study of slope and deflection in beams is important. The cross-section of a beam has to be designed in such a way that it is strong enough to limit the induced bending stress as a result of bending moment and also to limit the induced shear stress as a result of shear force that are both developed in the beam. This criterion is known as strength criterion of design. We have already covered this study in chapters 3 and 4 of this course. Another criterion for beam design is that the maximum deflection of the beam must not exceed a given permissible limit and the beam must be stiff enough to resist the deflection caused due to loading. This criterion is known as the stiffness criterion of design. We shall cover this study in the present final chapter on analysis of beams. It may be noted that under the action of external loads and external moments, any beam bends and suffers deflection at various points along the length. The deflection is caused by the bending moment acting at various sections of the beam. Deflection is also caused due to shear, but the magnitude is small compared to that due to bending, and hence it is generally neglected. Let us now formally define some terms for the sake of clarity and understanding. The vertical distance in transverse positions of the neutral or centroidal axis before and after loading at a section of the beam is defined as the deflection of the beam at that section. The shape of the neutral axis in its deflected position after loading of the beam along the length is known as its elastic curve or deflection curve. The slope of the beam at any section is defined as the angle in radians of inclination of the tangent drawn at that section to the axis in its deflected position after loading, measured with respect to the undeformed axis. The product of modulus of elasticity and area moment of inertia is known as flexural rigidity. More the value of area moment of inertia or the modulus of elasticity of the beam material, hence more is the flexural rigidity and more is the resistance to bending deformation. With this basic introduction, we shall look into some methods available to find slope and deflection in beams at any cross-section along a beam's length in the next lecture.